Hi there, we're on the last lesson of this unit. Congratulations, we went through all of the expressions lessons. We're gonna have a checkup at the end of this, so make sure you check your skills on that when we're all done with this. If you need to go back and review any of the videos for expressions, check the notes in your journal. If there was anything in there where there was like, I didn't really get this, so check the video again and do some more of those practice problems if needed. This last lesson though is gonna be kind of easy. And that's mostly because you've already done everything in this lesson, but we're just gonna make sure that we understand one more concept about expressions, okay? And that's equivalence. We talked about equivalent ratios. That's where one ratio has different quantities than another ratio, but they have the same value, all right? And that's kind of the same thing as equivalent expressions. One expression may look a certain way, and we may do something to it to make it look a different way, but they're gonna have the same value. And we actually have a way to prove that when we're done, okay? So, here's an expression. The first thing you should do when looking at an expression is, can I simplify it? Can you simplify this expression? Well, looking inside the parentheses, there's no calculation I can do inside because I don't know what this is. I can't take 7 away from something I don't know, okay? So there's nothing in here I can do. But I can still get rid of the parentheses with my magical power called the distributive property, right? I can distribute this quantity right here to both terms inside the parenthesis to get a new expression with no parentheses. Let's practice that again. I'm going to multiply 3 by both the x and minus 7, all right? When I multiply 3 times x, that's just like saying, well, I have an x, but now I need 3 times that many, which is 3x. 3 times negative 7, that says 3 times 7 is 21. This one is negative, this one's positive. Mr. Multiple Division, remember him, tells me that a positive times a negative is a negative. So now I have a new expression from here. It's very important that you recognize that even though these have changed the way they look, they are still equivalent. All right? Can I prove that? You betcha. What if I said, to evaluate, here's another skill that you've already done, evaluate both of these expressions if or when x equals 2, okay? And this will prove to us that these are equivalent, that they have the same value. So let's make sure that wherever we see an x, we replace that x with the parentheses. Let's open it up and put the value of 2 inside. Here, we have 2 here instead of the x, and over here, 3 times the 2 minus 21. Okay, and then we just calculate. This one, the order of operations tells us we have to do what's inside here first. Now 2 minus 7, we're taking a number that's bigger away from the original number, so I'm gonna go ahead and add the opposite here to make it simpler on me. Inside the parentheses right here, I have 2 different signs, so I'm going to subtract their absolute values. 7 minus 2 is 5. And we keep the sign of the bigger absolute value, so that's negative 5. Over here, 3 times 2 is what I have to do first before I do subtraction. So 3 times 2 is 6 minus 21. Okay? Now I only have one operation left on both sides. This one, 3 times negative 5. I know 3 times 5 is 15. And again, Mr. Multiple Division says plus times negative is negative. Equals, I'm going to change this subtraction to plus the opposite. 2 different signs, absolute values. 21 minus 6 is 15. Keep the sign of the bigger absolute value. And these are both the same number. So I've just proven by substitution, by finding the value, by evaluating these 2 expressions, that they are indeed equivalent, okay? These two are equivalent expressions, which I created just by simplifying one into the other, and then I proved that they're equivalent by plugging in some value for that unknown, okay? Where did I get 2 from? Top of my head, okay? I could have picked any number for x to put in here, and I still would have gotten the same numbers. Then it wouldn't necessarily have been -15, but they would have both been the same, okay? That shows equivalence. What if I have, let's do something else relatively simple. What if I have 3 times 7x? There's nothing going on in the parentheses that I can change or that I can do. So basically I just have multiplication happening, right? Instead of having 7x of something, I need 3 times that amount. So 3 times 7x is 21 x's, correct? These two are also equivalent ratios, okay? All I did was simplify one to get the other. They're both worth the same, they just look different. Can I prove that? Absolutely. Let's use 2 again, let's keep it easy. To prove this, so now I'm gonna rewrite this, and inside here I actually have 7 times 2, okay? And in here I have 21 times 2. Now inside these parentheses I do have something I can calculate, that's 7 times 2. So if I were to rewrite this, it would be 3 times 7 times 2 is 14. And over here I have 21 times 2, which is 42. It's just double that, okay? So if 3 times 14 is 42, I've proven that these two are equivalent, okay? 3 times 4 is 12, carry the 1, 3 times, there's 42, yep. There's the proof. Proving is a skill that you're gonna need a little bit later in the exercises underneath this video. But if you've done these calculations correctly, then you know they're equivalent. This is mostly if I came up to you and said, hey, look at these two expressions, they're equivalent. Are you gonna believe me? Are you just gonna say, okay, yeah, they're equivalent? Or are you gonna wanna prove it? And if you wanna prove it, pick any value for x, put it in where the x's used to be, and then do your math. And if you get the same number on both sides, you know they're equivalent. This is an incredibly important skill in mathematics. It's an incredibly important concept. And we're gonna get way deeper into this stuff in 7th grade. So make sure you have a good understanding that when you change one expression into another form, that you have equivalence, okay? For now, check out the exercises. And I will meet you in the video after that so that we can go over them together, okay?